Imagine a tiny robot, no bigger than a Lego minifigure. Now picture this little robot trapped inside a miniature jail, complete with tiny metal bars. It looks stuck, right? There's no way out. But then, something amazing happens. The little robot begins to melt. It turns from a solid shape into a silvery, shimmering puddle. The liquid puddle then oozes right through the bars of its cage, slipping through the gaps like water through a sieve. Once it's on the other side, it reforms itself, popping back into its original solid shape, completely unharmed and totally free. This isn't a scene from a science fiction movie. This really happened in a laboratory. Scientists did this to show the world what is possible. This incredible disappearing act is the work of a new kind of robot, a liquid metal robot. It's a machine that can switch between being hard and being soft. Think about it. Most things we know are either one or the other, but these robots can be both. So what are these amazing machines? Let's break it down. A liquid metal robot is a machine made from special metals that are liquid at or near room temperature. Think of mercury, the silvery liquid you see in some old thermometers, but much safer and more useful. These robots are not like your typical clunky metal machines. Instead, they are soft, flexible, and can change their shape entirely. They combine the properties of a liquid, like flowing, with the properties of a metal, like being able to conduct electricity. It's like having a robot made of programmable T1000 goo. At their core, these robots work by using a special type of metal alloy. An alloy is just a mix of different metals. The specific alloy used is often gallium-based. Gallium is a fascinating metal that melts in your hand. When mixed with others, it becomes a liquid at room temperature. Creating a liquid metal robot is like being a master chef in a high-tech kitchen. The main ingredient is almost always gallium. Gallium is a soft, silvery metal on the periodic table, element number 31. It has a super low melting point of about 30 degrees Celsius or 86 degrees Fahrenheit. That means on a hot summer day, or even just by holding it in your warm hand, a solid block of gallium will turn into a puddle of liquid metal. It's a real-life magic trick powered by basic chemistry and physics. But pure gallium can be a bit sticky and doesn't always behave the way scientists want it to. To perfect the recipe, scientists create an alloy. They mix the gallium with other metals, most commonly indium and sometimes tin. This creates something called a eutectic alloy, which melts at lower temperatures than the components. This gallium-indium alloy stays liquid at normal room temperature, making it much easier to work with. But the real secret ingredient is what they add next: magnetic particles. Embed magnetic flakes and you get a controllable magnetic liquid. The way these liquid metal robots move is completely different from anything we've seen before. Forget about legs, wheels, or propellers. These robots move by transforming their very bodies. One of the primary ways they get around is by changing their center of mass. Imagine a small, solid robot standing upright. By applying a magnetic field, scientists can melt a specific part of the robot, causing the liquid to shift its weight. This imbalance makes the robot tip over and fall in a specific direction. Then it can re-solidify and repeat the process, essentially walking by melting and refreezing one step at a time. Another fascinating method involves stretching and reforming, almost like taffy. They can make it thin enough to squeeze through a tiny crack or a narrow tube. Once it's through, release the field and surface tension snaps it back into shape. It can become a gripper, a scoop, or even a key on demand. The incredible abilities of liquid metal robots aren't just for cool lab experiments. They could be real-world superheroes across many fields. Imagine a tiny robot injected into your bloodstream. Guided by magnets from outside, it navigates veins and arteries. It could deliver medicine directly to a tumor, leaving healthy cells untouched. It could act as a liquid scalpel, performing delicate surgery from the inside. It could find and break up dangerous blood clots. In engineering, these robots could be the ultimate mechanic. Think jet engine, think data center server. A tiny component breaks deep inside. Normally, you'd disassemble the whole machine. Instead, send in a liquid metal robot to flow through intricate pathways and fix it. It can deliver a tiny drop of solder, perform the repair, then exit the way it came in, leaving the machine operational. For dangerous jobs, radioactive leaks, or chemical spills, sending people in is risky. Liquid metal robots can enter hazardous zones, assess damage, and seal cracks without risk to humans. They could enable self-healing electronics and smarter manufacturing. When you think of a robot, you probably picture something like a factory arm or a rover on Mars. These are what we call hard robots. They are built from rigid materials like steel, aluminum, and hard plastic. Their strength is, well, their strength. They are powerful, precise, and fast. But their rigidity is also their biggest weakness. They can't squeeze into tight spaces. Liquid metal robots, on the other hand, are the champions of soft robotics. Their main advantage is incredible adaptability and flexibility. A rigid robot arm could cause serious injury if it bumps into someone, but a soft robot would simply deform. The trade-off is often less strength and lower speed. Hard robots excel at brute force and speed. Soft robots excel at delicacy and access. Ultimately, the future is collaboration, a big, rigid robot deploying a team of soft bots. The hard robot does heavy lifting. The soft robots handle delicate repairs. This combination would create a robotic system far more capable than either alone. It's really the best of both worlds. Imagine the possibilities. Long before scientists were making them in labs, liquid metal robots were capturing our imaginations on the big screen. The most famous example is the T-1000 from the 1991 movie Terminator 2, a movie poster image of a shape-shifting villain next to a real-life gallium droplet. This terrifying villain was a shape-shifting assassin made of a mimetic polyalloy. It could melt through bars and form its arms into deadly blades and perfectly imitate other people. While today's real liquid metal robots are nowhere near that advanced, and thankfully not sentient, the T-1000 gave us a powerful vision of what such machines might look like. Real devices are controlled by external magnetic or electrical fields, and they remain silvery metal, not able to mimic complex organic textures or colors. Also, the T-1000 could think for itself. Our real robots are tools controlled by scientists, not independent minds. But the movie did get one big thing right. Machines without fixed solid forms have huge potential. Let's dive into some fun facts about the key ingredient, gallium. Gallium is a truly weird and wonderful element. It's one of the few metals you can safely hold and watch melt in your hand. But be careful, liquid gallium can embrittle aluminum. So what does the future hold for these amazing, squishy machines? We are standing at the very beginning of a technological revolution. In the near future, we can expect these robots to become more sophisticated and autonomous. Scientists are working on ways to make them move faster and with more precision. They are also exploring how to give them onboard sensors and simple processing power, so they won't always need a human with a magnet to guide them. Researchers envision robots made of many different materials working together. A soft liquid metal body for squeezing through tight spaces that can deploy rigid tools when needed. It might have conductive sections for electrical tasks, insulators elsewhere, and reservoirs for payloads. We might also see the principles applied on a much larger scale. Shape-shifting structures and adaptive buildings. Imagine a bridge that could temporarily liquefy and reform a section to let a tall ship pass. The field is still young. Power, control complexity, and biocompatibility remain challenges. But every small experiment is a step forward. This research lays the groundwork for programmable matter, still theoretical but promising. It's a future that is dynamic, adaptable, and wonderfully fluid. The journey is long, but the potential is enormous. We've journeyed through the incredible world of liquid metal robots, from their great escape to their future as medical superheroes. We've seen how science can take something as simple as a blob of metal and turn it into a machine of the future. It's amazing. It's exciting. It's all driven by one simple, powerful human trait: curiosity. It all starts with someone asking, what if? What if metal could be liquid? What if a robot could change its shape? What if we could solve a problem in a way no one has ever tried before? That's the spark that lights the fire of discovery. This science might seem distant, but the spirit of it is something you can carry each day. You don't need a lab coat to be a scientist. You just need curiosity. Stop, think about it, ask a question, look it up, talk to someone about it. Nurture your curiosity. That's one of the most powerful tools you have. The world is full of puzzles waiting to be solved. You have a brain perfectly designed for solving them. Be curious, ask questions, change the world. Consider this: you are a scientist. Now go out there and prove it. Like, subscribe, share to the greatness. 19 channel and click in the description box below for products and services.